Today's lesson is going to be one review topic and then adding something new onto the end of it. We're going to look at graphing linear inequalities. We've looked at graphing linear equations already. So a linear inequality is like an equation except it's not equal. An equation is equal, an inequality is not equal. So we're going to have a greater than or a less than in here. A solution is something that makes it true. And the graph will show those solutions. They're what are called half planes, which means that half of our graph area is going to be shaded. And that will be the region of our solution. To make the graph, we're going to graph the boundary line, which is the same as graphing an equation. So our first step is pretend like it's an equation and graph that line. We're going to use a dotted line if there is no equal to bar, and a solid line if there is an equal to bar. Just like when we did this on a number line, we used open and closed circles to denote whether or not that bar was there. Here we're going to use dotted or solid. Then we're going to choose a test point to see which side is the right side to shade. So first starting with some horizontal and vertical examples. Y equals -2 would be what kind of a line? Horizontal or vertical? Horizontal. So I'm going to cross the y-axis at -2. There is no equal to bar here, so I'm going to graph it with a dotted line. Then I want to shade on one side of this line. So the inequality says that y should be less than or smaller than -2. So where are the y values that are smaller than -2, above or below? Below. Shade this in, and that's what our graph will look like. Questions on that one? X is less than or equal to 1. What kind of a line would x equals 1 be?
Vertical.
A vertical line. There is an equal to bar, so we get to use a solid line to graph then. And the inequality says x is less than or smaller than 1. So where are the x values that are smaller than 1? To the left or the right?
Left.
To the left. Questions? Okay, so then if both variables are present, it's going to be some sort of a sloped line. This is actually in y equals mx plus b form, but it might not quite look like it. What's b? 0. Because this is like 2x plus 0, right? So our b value is 0, which means we have an intercept of 0. A slope of what? 2 over 1. So from that point, I'm going to go up 2 over 1. Up 2 over 1, up 2 over 1 as many times as I want, and I can go backwards as well. When I connect these dots, I'm going to do so with a dotted line because there's no equal to bar. I often forget that I'm supposed to do it, and I just kind of start connecting the dots and then remember later. So pencils are good because then you can just erase parts of the line. If you're doing pen, then, just writing next to it, like, dotted, and putting an arrow will tell me you knew it was supposed to be dotted, you just thought about it too late, and that's okay. Now we have to decide which side of this is the appropriate side to shade. To do that, I choose what I call a test point, where I'm going to pick one point that cannot be on the line. It has to be distinctly on one side or the other. So I'm going to choose the point 6, 6. I like to choose points where the x and the y values are the same, just because then I don't have to worry about what's what. It makes it a little bit easier to plug in. So I'm going to choose 6, 6, and I plug them in. 6 for x, 6 for y. I decide if this is true. 6 is less than 12. Is that true? Yes. So then that means that this point is supposed to be a solution, which means that everything on that side is in fact a solution. If you plug it in and you get something false, so let's say, for example, the point that I picked was this point. What is that point? Negative 1, 2. So then if I plug that in, 2 is y, and negative 1 is x. So I get 2 is less than negative 2. No, it's not. So that means that that point is not a solution, which means all the solutions should be found on the other side. Okay, so you pick a point. It does not matter what point. Plug it in. If it works, shade that point and everything on that side. If it doesn't work, shade the other side. Questions?
So we shade the side that has the solution.
Shade the side that has the correct solution.
Okay.
This one is not in slope-intercept form. If you are partial to graphing in slope-intercept form, and I noticed on the quiz that some of you are, that you like to solve for y, that's totally fine, but be very careful with this one. We'll walk through it together. Again, this is not my preferred way to do it, but in case you like to solve for y, what would I do first?
Subtract 2x.
Subtract 2x. Then what would I do?
Negative 5 or negative 5.
Divide every single part by negative 5, which gives y positive 2/5, negative 2, and what happened? I have to flip the sign. I divided by a negative. So that's a risk in doing this, is remembering to flip the sign. If you forget to flip the sign, you're going to end up shading the wrong side of the line. Okay. So that works. Now this is slope-intercept form, and you could graph it in slope-intercept form. Okay. So it's a fine way if you like to do it that way. It's not my preferred way. My preferred way is the cover-up method. Let's let x equal 0. If x equals 0, what do I get for y?
2.
Close.
Negative 2. And if I let y equal 0, what do I get for x? 5. So I plot those points. X is 5. Y is negative 2. Connect them with a solid line, because there is an equal to bar. And you can see this is exactly the same. Intercept of negative 2, slope of up 2/5. So it works either way. There's just, I think, a lot of places to make mistakes in trying to get y alone. So now we need to decide which side of this to shade. My favorite point to test is 0, 0. So if it's possible, I like to do that. The reason why I didn't on the last problem was because our line went through 0, 0. Okay? If your line goes through it, you can't test it. But otherwise, I always like 0, 0 because I think it's easy to plug in. So I'm going to go back to the original and plug in 0 minus 0 is greater than 10. So 0 is greater than or equal to 10? No. 0 is not greater than 10. So that doesn't work. And I shade down here. Questions on graphing or shading? So for this example, you could get y alone if that's your preference. I'm not going to. I'm going to let x equal 0, and what do I get for y? 4. So I can put a point on y is 4. Then I'm going to let y equal 0, and I get x is 2. Put a point on x is 2. Dotted or solid? Solid line, because there is an equal to bar. I'm going to choose to test 0, 0 because I can. And plug it in. 0 plus 0 is greater than or equal to 8. True or false? False. 0 is not greater than 8. so I'm going to shade over here. Questions?
How do you get the, if x and y are 0, what are y and x? How do you get those?
That's our other method of graphing, instead of solving for y all the time, is that we just take turns letting each variable be 0. So if x is equal to 0, the x part of the equation just goes away, and I'm left with 2y, we're going to say equals 8 while we're solving for these points, and that gives y is 4.
Oh, okay.
Then if I take a turn and let y equal 0, the y part goes away and leaves the 4x equals 8, which gives x is 2.
Okay.
So those give me my 2 points I can plot. It works to solve for y and just do slope-intercept form if that's your preference. You just have a lot of places to be careful. Other questions? Graphing or shading? Okay. This is from 2.6. We skipped over 2.5, so make sure you go to the correct section in the book here. And make sure you read your directions, because not every single one of these problems asks you to graph. That would be a lot of graphs to make. Okay, so make sure you read your directions.
Can I go to the book?